Hey guys, this is Rishendra. So today we will be starting large language models. Instead of the programming side, today we will look at some technical look at something on the technical side. So here, today we will be studying large language models. So large language models are a type of artificial intelligence model that can generate, um, understand, and process human language. So they are trained on massive amounts of text data such as books, websites, articles, research papers, and code to learn the patterns and the relationships and structures in language. In simple words, uh, LLM, large language models, are like a very advanced prediction system. So it predicts the next word or token based on the previous context. But because it has learned billions of patterns from the data, it can perform complex tasks like answering questions, writing code, summarizing documents, translating languages, and generating creative content. So, examples of popular LLMs include like ChatGPT, Gemini, or Claude, or Llama. Yeah, and how do large language models work? So the basic workflow of a large language model is like you will give an input text, and the input text will be taken by tokenizations and then token IDs, and then it will taken by transformer neural networks, and then by prediction of the next token, and then it gives a generated response. So, for example, you give an input like what is the capital of France, or like what generate me this image something. So the model predicts an answer, like it gives you the image that you wanted, and it will give you the capital city of France, which is Paris. So the model is not storing answers like a database. So instead, it learns statistical relationships between words, concepts, and ideas. So next topic is tokens and tokenization. So a token is a smallest unit of text that an large language model processes. So a token can be a complete word or a part of the word, a character, a punctuation mark. Uh, it can be any of these. So, for example, there's a sentence, um, artificial intelligence is powerful. So, the possible tokenizations is like artificial intelligence, artificial artificial intelligence is powerful. So instead of giving like one sentence, it will divide that one sentence into four different words. So the exact splitting depends on the tokenizer used by the model. So, why the question that comes up for this is why do large language models use tokens? So, computers cannot directly understand words. So they work with the numbers. Therefore, the text is converted into like numerous numerical representations. So, for example, if the text is like hello, so the token will be like 1 5 uh, 496 or maybe 15689. So it could be any of it converts the word hello into the token, and then the model processes like uh, that it first the text, then the text is converted to token, then the token is no, text to token, and the token converts it into the number, and the number will be given to the neural network. So next is the tokenization process. So um, how the process works in the tokenization. So here first is input the text. So first, what you will do is you will input any text you want. So, for example, you will input like my name is Friday, or my name is like John. You can input any text. And next step is the tokenizer splits the text into different lines. So if you give the text like my name is John or my name is Friday, so it will divide that one sentence into my name is John, or my name is Friday. So it will divide that one sentence into four lines. And then it will, and the next step is to convert these tokens into IDs. So it could be, here my will be converted into 40, into the number 40, or maybe 15. So these separate lines of words, they could be converted into any numbers. And the next step is mm, processing the numbers. So the transformer processes these numbers and generates the output for each of them. So there are like types of tokenization. So the first one is word level tokenization. So by the name, you can understand that it converts the words into each word becomes a token. So you can say, my name is John, and it converts the word into four different tokens. So the advantages of word level tokenization is like it's simple and easy to understand. So, but the disadvantages are like uh, it can't handle unknown words well, and it can't handle large vocabulary sizes. So if you do like programs, uh, if you do like the words programming or something else, yes, it would understand. But but the words it has a but the words, yeah, it has a limit on how many words it can use. So yeah, and the next one, so Next, in types of tokenizations. So the next one in types of tokenizations is character level tokenization. So here in character level tokenization, so in word level tokenization, each word becomes, if you write a sentence, each word becomes a token. But in character level tokenization, the each letter in the word becomes a token. So if you write like the letter word hello, so here hello has 5 letters. So these 5 letters become in 5 individual tokens. Uh, the advantages are like so it handles any word and it is only useful for like a small vocabulary. So it has a limit on the size of the vocabulary that is used. And the disadvantages are like so it requires many tokens and it is less efficient than the word level tokens. So next one is sub-word tokenization. So modern LLMs, modern large language models, they use sub-word tokenization. So here a word can be broken into smaller pieces. So here if you take a word like unbelievable, so here it can be broken down into 3 parts, which is like it can be broken down into unbelievable. So here the one word unbelievable can be can be converted into 3 different words. Next one is context. Next topic is context window. So the context window is the maximum amount of information a large language model can process at the time. So at one time. So it includes user input, previous conversations, um, instructions, or maybe a generated response. So if a model has a for example, if a model has like a context window of a like let's say a 128 tokens, 128 thousand tokens. So it can process approximately 100 pages of text at once. So, example, if you take a small context window like uh, explain chapter 1. So the AI reads chapter 1. But if you take a large context window, like here are 10 research papers, combine them, compare them. So the model can analyze all the papers together. So while it can be useful, it has a large context windows. There are limitations of how much context window you can put. So, like even with large context windows, the model may forget earlier information, and so and maybe like more tokens require more computational, more computations, and very long context can reduce accuracy. So next topic is prompt engineering. So prompt engineering is the process of designing effective instructions for a large language model to produce better responses. So a prompt is the input given to the AI model. So it could be like a poor prompt, like for example, explain AI, or it could be a better prompt like explain artificial intelligence and explain it like I'm a beginner and include the examples and real world applications. So whatever prompt you give, like it could the better the prompt, the better the answer you may get for uh, and the AI can generate. So there are types of prompting techniques. So the first one is zero shot prompting. So zero shot prompting, the model receives a tasks without receive a task without examples. So, for example, you can do like translate this sentence into um, English, or maybe translate this sentence into French. So, and you will give like just one word, hello. So it's like the model already knows the tasks. Then there's few shot prompting. So this is the second one, few shot prompting. So this gives the users examples. So unlike zero shot prompting, the few shot prompting, it provides examples for the prompt given. So for example, if you the user provides the examples. So, for example, if you give the prompt like convert English to French, and you will give example like, uh, for example, the hello will be converted into bonjour. So, you will give a example first, like this should be converted like this, and then you will give what word you wanted to be converted from English to French. So, so that the model learns the pattern from the example that the user gives. And then the next one is a chain of thought prompting. So this model is encouraged to reason step by step. So chain of thought prompting, so it's mostly used in mathematics or logical problems. So if you want a problem, like instead of just the answer, you want step by step explanation of the problem. So that is called chain of thought prompting. So you want a instead of just the direct answer, you want the step by step process and the reasoning. And next one is role based prompting. So role-based prompting is like giving AI a role. Like for example, you can ask AI to act as an instructor, or you can ask AI to act as an interviewer, or you can ask AI to act as an police officer. So you can give AI a role based on what you are typing. So, and the last one is structured prompting. So, structured prompting is so structured prompting is like providing clear sections. So, for example, instead of just typing explain machine learning, you can type like explain machine learning, and you can give requirements like you want the definition, you want the algorithms, and you want examples. So instead of typing just machine learning, you will type machine learning, and you in the at the bottom you will write give definitions, explain algorithms, or provide examples. So you can use so these are the different kinds of prompting. So yeah, that's it for today, and um I'll see you again tomorrow. So yeah, thank you. Bye.